This is CPM Calculus Chapter 3, number 177. So write a Riemann sum to estimate the area under G between G and the x-axis between 0 and 2. Alright, for G is defined to be negative x squared plus 4 using n left endpoint rectangles. Alright, so we know Riemann sum is using sigma notation, right? N left rectangles means that we're going to start with our variable, whatever letter we like. I'm going to use k. We could start from k is 0 to n minus 1, right? Whatever n is, we subtract 1 from it, all right? The base, so the area of each rectangle, right? Remember, the area of a rectangle is just base times height. So the base is going to be the width, right? Base is the width of every rectangle. And remember, that's just going to be the total width from 0 to 2, so 2 minus 0 is that distance, divided by how many rectangles we're splitting up. So that's over n. So that's just 2 over n. So the base is going to be 2 over n. And what's the height? Well, the height is basically going to be our function's value at 0, plus each width, okay? So it's just going to be times g, our function, starting at 0, and we're going to start at 0, and then every time we're going to add the width, okay? So let's go ahead and write the width as 2 over n, and we're going to do this for every k, okay? So this right here is the Riemann sum, and let's go ahead and plug it into our function here, right? So to plug this in, let's go ahead and do that. From k equals to 0 to n minus 1, 2 over n. G, so we don't have to write 0 again, but g of 2 over n times k, we're going to replace where we see x, so it's going to be negative 2 over n times k squared, right, plus 4, right? So that is the expression for the Riemann sum to estimate the area between G and the x-axis from 0 to 2. All right, so part A is asking us to go ahead and calculate this sum for n is equal to 20. Okay, so that's where we go ahead, and for n is equal to 20, the sum is going to be k is equal to 0 to, instead of n minus 1, we're going to go to 19. 2 over 20 here, right? 2 over 20 times negative 2 over 20, the width of each rectangle, times k squared plus 4. All right, so we can use our calculator to do this for us. Let's bring out our calculator, right? Turn it on. We can quickly get to the sum using catalog. Let's go all the way to the end of, let's go all the way down, oh my goodness, here we go, the end of S, and we get that, right? So then we want to, it even says how to enter it in. We write the expression, the variable, low and high. So the expression is this whole thing, right? So let's go ahead and enter that. That's 2 divided by 20 times, and then I'm going to open up the parentheses, negative of 2 divided by 20 times k. So to get k, I have to use alpha here, right? So I'm just plugging this in, squared plus 4. Oops, I put 7 plus 4. Comma, the variable I'm using is k, so I'm going to use alpha, k. The low is where I start. My starting index is 0, so comma 0. My stopping index is 19. Enter. Oop, I'm missing a parentheses. Let's go back and make sure I have all the parentheses. Right, 2 over 20 times this whole thing, and I forgot to close my parentheses here. Enter now. I can go ahead and check what it looks like here to see if it matches. Yes, k equals 0 to 19. 2 over 20 times negative 2 over 20k squared plus 4. Yes. And I get 553 over 100. Okay. If I want to get the approximation, I push the green diamond and enter again. And it's going to tell me approximately, or it's actually equal to 5.53. Right? I want to say approximately in case we rounded, but we didn't round. That's exactly 5.53. Okay. So let's go ahead and do part B. Part B says, how can you use your result to estimate the area between G and the x-axis from -2 is less than or equal to x is less than or equal to 0. So let me put away the calculator. So what changed? Well, basically we went from 0 to 2 here, right? And now we're going from -2 to 0. Well, let's examine g of x. Okay, so let's go ahead and graph it really quickly. I'm going to graph it, so I'm going to use my calculator to graph it for me. That's basically negative x squared plus 4. All right, let's go ahead and graph it. Ooh. All right, so I'm going to see what it looks like. Let me zoom standard because I think I'm zoomed in a weird way right now. Right. Okay, so this is basically my parabola reflected across the x-axis and shifted up by 4, right? Well, what's the special feature about this function? It has symmetry with respect to the y-axis, right? G of x is even. All right, so what that allows me to do then is to say, if it's even, then if I look from -2 to 0, that's the same as when I look from 0 to +2. So I can use the fact that it's even to say this is equal to the area from between G and the x-axis between 0 and +2, right? Because it's even, I can look at the other side and it's going to give me the same thing. Okay, how can you, so we can estimate it then, it's going to be the same thing, 5.53. Also, they ask, well, what about the area between G and the x-axis from -2 to +2? All right, well, since we know that it's the same thing from -2 to 0 as 0 to 2, we can basically say, well, this is going to be 2 times the area between G and the axis from 0 to +2. Or we could say it's 2 times the area between G and the x-axis from -2 to 0. Okay? So this is basically what we can do. We can then multiply that area times 2. 2 times 5.53 is equal to, let's go ahead and go home. Multiply 2 times this, and that's equal to 11.06. Okay, so that's how we can estimate this area. All right, so this is how we can go ahead and find the Riemann sums and use the features of even functions, right? To look at the negative side being the same as the positive side with the same values here, right? And that ends CPM Calculus Chapter 3, number 177.